Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will review everything covered in week 12. We'll start with finding antiderivatives. The process of finding antiderivatives is called integration. So you already know this. You know the derivative of x squared equals 2x. This here says the integral or antiderivative of 2x is x squared. You see, differentiation and integration undo each other just like multiplication and division undo each other. If you differentiate a function and then integrate your answer, you're back where you started. So the reason the integral of 2x is x squared is because if I differentiate this, I get this. Integration is saying what function do you differentiate to get that function. Now, there is a slight problem with this equation here. Now, what I said was true. If you differentiate x squared, you do get 2x. But if I were to differentiate x squared plus 1, I would get 2x. If I were to differentiate x squared plus 2, I would get 2x. So when we're performing integration, we need to write this plus c at the end. C just means constant. If I differentiate x squared plus any constant, I will get 2x. So this line here just spells out what I already said. It's saying if you integrate the derivative of a function, you get the original function. We have to add a plus c because if I differentiate fx plus c, I'll get f dash x. Constants vanish when you differentiate. So we've only looked at differentiating powers of x, so we're only going to look at integrating powers of x. So when you differentiate a power of x, you move the power to the front and decrease the power by 1. When you integrate, we do the opposite. So to integrate x to the power of n, you increase the power by 1 and divide by the new power, making sure you add the plus c. So let's look over here. So the integral of x, well, you know x is the same as x to the power of 1. So to integrate, we simply increase the power by 1, divide by the new power, and then we have to add plus c. So if I differentiate x squared on 2 plus any constant, I will get just x. So when you differentiate a whole heap of terms, remember we differentiated them one by one term at a time. We can do the exact same thing for integration. To integrate this function here, I'm going to integrate each of these terms one by one. So to integrate 3x squared, what we kind of do is leave the 3 alone for now. We'll just write it, leave it alone. We're going to increase the power by 1, and we're going to divide by the new power. So, of course, these 3's cancel out. The integral of 3x squared is x cubed, because if I differentiate x cubed, I get 3x squared. So similarly here, the integral of 4x, well, I'm going to increase the power by 1, divide by the new power. Of course, 4 divided by 2 just equals 2. And so it's 2x squared. If you differentiate 2x squared, you get 4x. Now, when we differentiate, constants vanish, but that's not true for integration. So how do we integrate 1? Well, I'm saying, what do I differentiate in order to get 1? So this is kind of like 1x to the power of 0. So you increase the power by 1 to get x to the power of 1 and divide by the new power. So it's just x over 1 or x. If you differentiate x, you get 1. Of course, because I'm integrating, I need to remember to add the plus c. So if I differentiate x cubed plus 2x squared plus x plus any constant, I will get this function here. All right, let's try this one here, which is a little harder. So the reason it's harder is it's not in this form. So I'm going to write it like this, so it looks like this. So it's just x to the power of something. By the way, dx just tells us that we're integrating with respect to x. You can sort of ignore it when you're integrating. So to integrate x to the power of a half, what I'm going to do is increase the power by 1, so it'll be 3 over 2, and divide by the new power. But remember, dividing by 3 over 2 is the same as multiplying by 2 over 3. So this is the antiderivative of that, because if I differentiate this, I get that. Now, what's the integral of negative x to the minus 2? Well, we're going to use the same process. We're going to leave the negative 1 alone. As it is, we're going to increase the power by 1 and divide by the new power. So, of course, these two negatives cancel out to make it a positive. And I can write x to the power of minus 1 as 1 on x. And because I'm integrating, I need to add the c. All right, let's now move on to straight line motion. So we're now going to look at the displacement, velocity, and acceleration of objects moving in a straight line. So displacement is like distance and velocity like speed, except displacement and velocity can be negative. So we're looking at an object moving in a straight line. Positive displacement means it's to the right of O, the origin where it started. Negative displacement is to the left of O, where it started. So a positive velocity means it's moving towards the right. A negative velocity means it moves towards the left. So we know that velocity is just the rate of change of displacement with respect to time. But hang on a minute, differentiation is finding the rate of change. So if you differentiate displacement, you get velocity. Similarly, acceleration is the rate of change of velocity with respect to time. So the derivative of velocity is acceleration. So we now know integration is the opposite of differentiation. So to go the opposite way, you integrate. If you integrate acceleration, you get velocity. If you integrate velocity, you get displacement. So for some reason, displacement is often given as x, and the variable we're interested in is t. T is time. So it's probably x because we're looking at things going left and right, but you've just got to get used to that. So let's look at this question. Particle travels in a straight line. This displacement function gives its position relative to the origin, relative to where it starts. So x is in centimeters, the number of centimeters it is from the origin after t seconds. So we're going to calculate each of these four things. Let's start with average velocity. So the average velocity is the average rate of change of displacement. Remember, when we find the average rate of change of a function, we don't differentiate it, we just use the gradient formula. So the average rate of change from t equals 0 to t equals 4 will be x4 minus x0 all divided by 4 minus 0. So the answer I get there is minus 10. Because x was in centimeters, it's centimeters. Because t was in seconds, it's centimeters per second. So remember, the instantaneous rate of change of a function is the derivative. If I want to find the velocity at 4 seconds, at that instant in time, I need to differentiate displacement and substitute 4 for t. So differentiating x with respect to t, I get 6t minus 3t squared. I'm just using the rule, move the power to the front, decrease the power by 1. So substituting in t equals 4, I get negative 42 centimeters per second. So this one is traveling very quickly, 42 centimeters per second, but it's going to the left. That's why velocity is negative. So let's look at the instantaneous acceleration. Well, acceleration is the derivative of velocity. This was my velocity equation. So I differentiate this to find the acceleration. So remember, x double dash t means the derivative of the derivative. If I differentiate this, move the power to the front, decrease the power by 1, constants vanish when you differentiate. So the derivative of this is this. This is my acceleration function. So if I want to know the instantaneous acceleration after 4 seconds, I just substitute t for 4. I get negative 24. Now, acceleration is always in units per time squared, in this case, centimeters per second squared. All right, the last one says, when is the particle stationary? So stationary means it's not moving. What it means is that the velocity is equal to 0. So this is my velocity equation here. I want to find where it equals 0. You can use the quadratic formula or polynomial solver. You get t is plus or minus 1.4142, blah, blah, blah. So, of course, that's in seconds because t is in seconds. So, in this case, we don't have negative time, so we don't need to worry about that solution. We'll just take the positive solution. So, after about 1.41 seconds, that means that the velocity is 0. That means the particle is stationary. All right, let's now look at sketching a velocity graph. So here we have a displacement graph. Let's say it's for a particle. We're going to use this to draw the velocity graph. So just note, this is not the trajectory of the particle. It's not moving in a curved fashion up and down. It's starting at the origin. It's moving in a straight line back and forth. So let's look at this graph to tell the story of what's happening to the particles. So at 0, the displacement 0. It starts at the origin. So what happens is the gradient here is quite large. It's actually traveling pretty quickly to begin with, but then slowing down. So the particle starts here. It travels pretty quickly, then it slows down. After 4 seconds, the particle stops and turns around. That's what this turning point here means. So now the velocity is going to be negative. That means that the particle is going to start moving back to the left. So here, the velocity becomes negative. It starts off slow and picks up speed. So it starts here, starts off slow, and it picks up speed. It goes through the origin again after 6 seconds, and it keeps going. The displacement's negative means it's now to the left of the origin. So it again starts slowing down, and after 8 seconds, it's going to stop again here and turn around. And then it goes in the other direction, it picks up speed, and it goes through the origin again after 10 seconds. So the velocity graph looks like this. As I said, it's got a positive velocity. It's going quite quick to begin with, and then it slows down. It stops. Velocity is 0 after 4 seconds. Then the velocity is negative between 4 and 8 seconds. And then the velocity becomes positive. The particles started moving to the right again. All right, let's look at now a harder question involving integration and straight line motion. So let's try this question. Ball thrown from ground level, initial velocity 39.2, acceleration negative 9.8. So negative acceleration means that the velocity is decreasing, the ball is slowing down, and that's due to gravity. So we're going to calculate the maximum height reached by the ball and how long it takes to return to the ground. So both of those require me to know the equation for displacement. So how am I going to get that? Well, first I'm going to calculate the equation for velocity. So remember that the velocity is just the integral of the acceleration with respect to t. That dt means my answer will have t's in it. So if the acceleration is negative 9.8, the velocity is just going to be negative 9.8 t, and remember when we integrate we need to add c, a constant. So sometimes you'll be given an extra bit of information allowing you to find what c is. In this case, we're told initial velocity 39.2. That means if I substitute t for 0, v is equal to 39.2. So I get 39.2 equals negative 9.8 times 0 plus c. So c is 39.2. Always c will be whatever the initial velocity is. So this here is my velocity equation. So if I want to find the displacement, I integrate the velocity. So the integral of negative 9.8 t, so remember you increase the power by 1, divide by the new power, I get negative 4.9 t squared plus 39.2 t. Now here we add a constant, but what we're going to do is we're going to let x be the height above ground. So initially the height above ground was 0, so c will be equal to 0 in this case. So what is the maximum height above ground? So this cricket ball has been thrown up in the air, straight up, and then eventually it's going to stop, turn around, and come back down to the ground. So the maximum height will be when the ball stops, i.e. when the velocity is equal to 0. So if you solve 9.8t plus 39 equals 0, you actually get t equals 4. The velocity is 0 when t equals 4. So what is the height of the ball when t equals 4? Well, I just have to substitute 4 into there. So I get x4, substituting that in, I get 78.4. So because everything was like meters per second, this will be 78.4 meters. That will be the maximum height, and it'll be reached after 4 seconds. So how long does it take the ball to reach the ground? So after it's gone up and stopped and turned around, it'll eventually come back and hit the ground. So when it hits the ground, the height above ground is 0, the displacement is 0. So all I need to do is solve xt equals 0. So if you solve this equal to 0, you can use the quadratic formula or polynomial solver. You get t equals 0. Well, that makes sense because the ball started at ground level, and we also get t equals 8. So it will return to the ground after 8 seconds. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.